Hello everyone, welcome back. We have been discussing about the fundamentals of logic design. So let's have a quick recall before we start with this discussion. So quick recall. What did we see? We saw logic design, correct? So what did we understand? Especially we were talking about circuits which will take decisions for us, correct? So we were talking about binary decision making, correct? What are that? Yes, no, on, off, true, false, 1, 0, high, low. These kind of decisions, binary decision making, correct? And we saw that a circuit which is capable, or a module which is capable of making a binary decision can be used for automation. So we saw an example about watching the movie also, like the star cast is good, or the story is good, or the screenplay is good, and you have the time to watch the movie. You take a decision to watch the movie, correct? This is what we discussed last time. Okay, so now we will look more into this binary portion of this decision making. So binary logic. So as we are seeing, the binary logic is going to take decisions like this: yes, no, on, off, true, false, 1, 0, high, low kind of decisions. Okay, so now let's look at fundamentally all these things requires max. Say for example, think about what we did in the electricity current discussion also. So like we are multiplying now, like Ohm's law says V equal to I into R. And also we saw about examples about adding voltages, subtracting voltages and all. So it was, so basic science always requires a fundamental mathematical background to build upon. So similarly for binary logic also we need fundamental maths, which is going to be called as binary arithmetic. We will quickly look at binary arithmetic. And also look at something called as Boolean logic and Boolean algebra. Okay, we are going to look at this. So binary arithmetic means what? We are going to use only 0 and 1 to represent numbers. Correct? So only 0 and 1, that's it, nothing else. We call, see, for example, the conventional number system, whatever we are using, it's called decimal arithmetic, correct? Decimal number system. Why it's decimal number system? We use 0, 1, 2, so on till all the way till 7, 8, 9, correct? There are 10, you have 10 representations of the numbers, correct? 0 to 9. So all the numbers are represented using 0 to 9 digits, correct? Like say for example, you want to represent 45, it is, so this is 4 times 10 plus 5 times 1, correct? Correct? Whereas if you want to represent the same number in binary arithmetic, we cannot use the digits 4, 5. I have to represent it using only 0 and 1. We will see how to do that. Okay, and also we will look at the ways of representing the logical operations and what is the algebra behind that. Okay, this discussion will be based on that. So first thing, let us use this example itself, 45. So you have a number called 45. So the digits are weighted by the powers of base. And what is the base? Base is the number of representations I have. Here I have 10 representations. Correct? So the base is 10. Correct? Look at the decimal number system. You have 0 to 9. So this is 10 different representations. Because you have 10 different representations, the digits are weighted by the powers of the base. So the base is 10. So when I say 45, the weight of this digit is 10 power 0, which is 5 into 1. The weight of this digit is 4 into 10 power 1, which makes the number as 45. Similarly, if you take a number called, say, 227, this 7 is weighted by 10 power 0. This 2 is weighted by 10 power 1. This 2 is weighted by 10 power 2. So you are having 227. So when you sum it, you get 227. Correct? So the digits are weighted by the powers of base. Similarly, if you have a number 101 to the base 2, this is a binary number. This is not our 101. So 101 to the base 2 is not same as 101 to the base 10. 101 is 101, correct? This is not, these two are not same. What is this 101 means? This 101, like here the powers were weighted, the weights were based on the powers of the base. Here this 101 means this is 2 power 0. This is 2 power 1. This is 2 power 2. So this is 4, 0, 1. So this means it is actually 5. As per our decimal number system, this number is 5. Correct? Similarly, if I take, suppose 1101 to the base 2 means what? This is into 2 power 0, 0 into 2 power 1, 1 into 2 power 2. This is going to be 1 into 2 power 3. 2 power 3 is 8. 2 power 2 is 4. 2 power 1 is 0. 2 power 1 is 2. Multiplied by 0 is 0. 2 power 0 is 1. Multiplied by 1 is 1. So this is 13. Correct? So now, this was a quick introduction for converting the binary number to a decimal number. Okay, now let us look at Boolean algebra.